Continuing on here in section 6.4, to write an expression in simplest form, write every exponent as a positive number. So if we look here in example 6, we're writing expressions in simplest form. What is each expression in simplest form? Here, first thing I'm going to do is, since I have a rational exponent there, I'm going to rewrite this with a rational exponent as well. So I'm going to have negative 8x. xy is my radicand, so that whole thing I'm going to put in parentheses. And my exponent on each of those is a 1. And my index is a 2. Now I need to raise the whole thing to the 2/3 power. Okay, I have inside, I have a product to a power, so I'm going to take that half power to each factor here. Negative 8 times x to the 1/2 power times y to the 1/2 power. And all of that is raised to the 2/3 power. I can multiply these together by adding my exponents, and I get 3/2 y to the 1/2. So I've simplified inside my parentheses the best that I possibly can so far. Now, just like I did here with my half, I'm going to do the same thing with my 2/3. I can take that 2/3 as an exponent to every factor inside my parentheses. Because the 2/3 is touching this parenthesis, it goes to everything inside there. So I have negative 8 to the 2/3. I have x to the 3/2 raised to the 2/3. And I have y to the 1/2 raised to the 2/3. Okay, negative 8, I'm going to rewrite. It's the cubed root of negative 8 squared. Index and my denominator match. Exponent and numerator match. Negative 8 is negative 2 times negative 2 times negative 2. Looking for groups of 3, I have a group of 3. So I have negative 2 squared from my exponent there gives me 4. Here, I multiply. Power to a power means I multiply my exponent. So I take 3/2 times 2/3. I get 6/6, which is 1. So I have just an x. And same thing here. Power to a power means I'm going to multiply 1/2 times 2/3. Give me 2/6 or 1/3. So y to the 1/3. Now, we want to write this, since we started with a radical here, I'm going to write it as a radical. So, my 4 and my x don't have any rational exponents, so those can just stay. But I got to get rid of this 1/3 here. So my base becomes my radicand, my numerator becomes my exponent, and my denominator becomes my index. And I get 4 times x times the cubed root of y. Same idea here. What I'm going to do first, though, since we don't have anything to simplify inside our parentheses, is to distribute. Some of you might have gotten rid of the negative first on your 3/4, and that works as well. But I'm going to go ahead and distribute in first. I'm going to have 16 to the negative 3/4 power, and it stays an exponent, guys. It just goes to everything it's touching, which means everything inside the parentheses. And as long as we're multiplying, that works. It's got to be a product. Here, I'm going to rewrite this so that it's positive by moving it to the denominator and changing my exponent to be positive. Here, I'm going to multiply. Because I have a power to a power, it means I can multiply my exponents. Again, I have those on the back wall next to the happy face parabola through the corner. It's going to give me positive 24/4 to the 6th. And again, that was y as my base, so I keep that as y to the 6th, and I bring it over here. I still need to simplify this part. So I'm going to rewrite 16 as 16. My base becomes my radicand. My denominator becomes my index. And my numerator becomes my exponent. And again, it doesn't matter if that 3 is on the outside or inside with the 16. Doesn't matter at all. 16 is 4 times 4, or 2 times 2. So I get 2 to the 4th power. I'm looking for groups of 4. I have a group of 4. So I have 2 cubed. And again, that's in the denominator here, which is 1 over 8. And I have to cube it because of my exponent there. So what I have right now in this column is 1 over 8. And here I have times y to the 6th. So I have y to the 6th over 8. Go ahead and pause here and give these a try if you'd like. Two options here. I can either distribute my exponent right away since I have a power to a product to a power here, or I can make this positive first. On the last one I distributed right away, so here I'm going to make it positive first just to show you another look at it. So to make this positive, we move the whole thing to the denominator, and the only thing that we change here is that exponent to be positive, and there's a 1 in the numerator. Now, just like I did before, anytime I have a product to a power, I can take that power and distribute it. So I have 1 over 8 to the 1/3 times x to the 15th power raised to the 1/3. 8 to the 1/3 is the cubed root of 8. I'm looking for groups of 3. I have a group of 3 with my 2's. So instead of 8 to the 1/3 power, I'm going to put a 2. Now, power to a power here means I'm going to multiply my exponents. So I'm going to take 15 times 1/3 and get 5. So I have x to the 5th. And everything is as simple as I can get it there. I'm going to go ahead and start by getting rid of my radical for the time being. Since I have a rational exponent here, I'm going to write this whole thing in exponential form, which means we want exponents. So 9 times x, my radicand becomes my base, my exponent becomes my numerator, and my index becomes my denominator. And again, that whole thing is still raised to the 3/2 power. Now, I can go ahead, and because everything inside my parentheses is being multiplied, it's just one big factor, or one big term. So each factor can get that exponent. So I have 9 to the 3/2 power, x to the 3/2 power, and y to the 1/4 raised to the 3/2 power. My number here, I'm taking the square root because my denominator is a 2. My base becomes my radicand, and my numerator becomes my exponent. Square root of 9 is 3. Cubed gives me 27. I can multiply here. Power to a power means I multiply my exponents. And I get 3 over 8. I can also, 3 divided by 2 gives me 1, remainder 1. So I have 1 full x outside, and I'm left with 1/2 inside. Okay, 3 over 2 means that I have 3 x's inside a square root. I'm taking out a group of 2 of them as an x right here, and I'm left with 1 left. When I look here, I want my denominators of those fraction parts, okay, those rational exponents, to be the same so that I can write them in one radical. So common denominator between 8 and 2 is going to be 8. So to get to 8, I need to multiply by 4 top and bottom. So I have x to the 4/8, y to the 3/8. And I know that seems silly because our x isn't as simplified as we can get, but now that my denominators are the same, I can write it as a single radical. So that denominator becomes my index. My exponent comes from my numerator in both of my variable terms. So I have 27x times the cubed root of x to the 4th power y cubed. And this is as simple as I can get it because I have exactly one radical and everything that can come out is already out. Recap here for this section. A radical expression can be written in an equivalent form using a fractional or rational exponent instead of a radical sign. So the nth power of x equals x raised to the 1 over nth power. This is our radical form. This is our exponential form because it has an exponent. And that works for any positive integer n. If it's a negative integer n, guys, we have to move it to the denominator or from the denominator to the numerator to change that sign. Like the radical form, the exponential form indicates a principal root. The nth written expression that contains an nth power as a factor can be simplified. So the nth root of x to the nth power is just x if n is odd, and the absolute value of x if n is even. And that's all I have for section 6.4.